Can I start? Okay. Hello, everyone. I'm also from the Yokohama National University. My name is Chikako Fujiyama. So today's my topic is the fatigue of civil engineering structure. Actually, you may know the fatigue of the steel structure is one of the big research topics. But today, I would like to focus on the fatigue of concrete. I think fatigue in Indonesia may be fatigue. Yeah, something similar pronunciation. Okay, please see, these are the several examples of fatigue failure of concrete structure. This is one of the bridge slab that Professor Maekawa already introduced to you. And this is the wind turbine. Then I will talk about this one later. But anyway, this kind of accident occurred in Japan. So, yes. Okay, let's talk very beginning basic level, and I will talk about the research. But the first, what is the fatigue of concrete? We should clarify the problem. As you know, the fatigue is the small amplitude, but the number of cycles is so huge. So in the engineering viewpoint, so generally speaking, million cycle is the fatigue limit. Then if we consider this is like, please imagine something stress of structure. High intensity but low frequency, it's like the earthquake. I will show you some real observed wave motion later. Then the low intensity is like that. It's like very irritates you, very small stress, always your mom clean up, study, then finally you get angry, something like that. But anyway, these are the fatigue problem. Then what is the source of the fatigue in this civil engineering? Yes, one is a wave. Wave, every day, I don't know how many waves come to your coastal area, and wind also, and the traffic and the trains, of course, source of the fatigue problem. Then, yeah, this time I don't talk about earthquake. Then, yeah, okay, this is the same one. So please see this one. Why fatigue of civil engineering structure shows this delicious pound cake? I just want to make it easy. This is like concrete. Also, looks delicious. Yeah, concrete has fine aggregate, small the dry fruit powder, and also the coarse aggregate, maybe dried grape, I don't know. Then we have the cement matrix as a binder, and also we have the void, yes, like this. So why I show this one to you? Because I'm hungry? No. I want to explain the fatigue of concrete. As you learned, there is an aggregate in concrete. And this aggregate, as Maika sensei said, have the weak interfacial transition zone. And also, this kind of shape makes some stress concentration. Then small cracks occur. even if the stress, the action force is very small, inside concrete, this kind of small cracks occur. Then after the cycle, these cracks developing, and finally it connected each other. Then it causes very big collapse of structure. Yes, this is, I think if you join the Yani-san's classroom, I'm not sure she explained the stress and strain. Yes, this black one is the static, under the static loading, the stress-strain relationship of concrete is like this one. But if we apply load, small load gradually, yeah, this, like these red lines, you can see the decrease of stiffness and the increase of unrecoverable deformation, plastic deformation. Yes, these are the explain of fatigue of concrete. And I would like to explain my experience. My cousin said the fatigue and the shear failure of the concrete is something similar to our bone failure. Okay, 2 years ago, I got the cold. Yeah, then also together with allergy of the pollen, then I cough. Almost 3 weeks, cough every day. Then finally, I had some pain in my breast. Oh, what happened? Then I went to see doctor. Then he took my X-ray photo. Then he said, okay, your rib bone was broken because of the fatigue, cough. Continuous cough. Then I asked him, please show me the X-ray. Okay, the one side shows very clear shear failure. Yeah. Then another side, I don't remember, but there are some micro cracks. So at that time I was so happy. I studied about fatigue of concrete for 10 years. Then finally, I got it in my body. So anyway. Okay, the water is one of the big problems. Acceleration factor of the fatigue of concrete. You can easily imagine if you want to have a snack. If it's very dry, you need force to crack it. But if you put it in the soup, it's easy to break down. This kind of example can make you, give you a better understanding. Then anyway, we found many crashes like this one under the pavement, and it always submerged or wet condition. But if you know the design of the bridge structure, and if you can calculate the bending moment, of course, you can do it. The stress amplitude of the top slab is very low. It's just less than 1/3, 1/5. For example, the compressive strength of concrete is 30 megapascal. But if the car come and pass through this bridge, the maximum compression stress is like 3 megapascal, 4 megapascal, something like that. So this kind of failure and damage should not be observed. But actually there is the damage. Then Yes, I want to verify the effect of water. This simple experiment is done by my student. There is the concrete block with notch, and apply some force here and give some water pressure. Then finally some powders, binders will flow out from the concrete. This is my expectation. Then, okay, we set up this kind of very simple hydraulic jack and simple water tank and make simple concrete specimen. Then, yes, apply load by hand, by hydraulic jack. Okay, my student said, Sensei, okay, I tried 1,000 cycle. What happened? Nothing happened. Okay, let's do it more. Then he said, okay, I did it 5,000 cycle. Nothing happened. Okay, you are very strong. Please continue. Then, yeah, finally 10,000 cycle. Yeah, something like that. Then, yeah, there is some conditions, but because of the time limitation, I just skip. So we found something. So for example, this is the submerged just 0.5 hours, then applied force and water pressure. The absorption water line is clear. Then the flowed the material is low. But if we absorb 72 hours, the submerged the specimen, then after that we apply load. So many, it's very difficult to distinguish in the picture, but anyway, you can see many flow out from the specimen. Then we measure the flow out materials and make analysis. For example, we measure the water pressure during his 10,000 cycles. Then please see this water pressure is not so much high, just kilopascal, 500 kilopascal maximum, and mostly just 200 kilopascal. It's very lower than the concrete strength, of course. Then I decided the water pressure and concrete strength should be the index of damage. Then make some graph. The result is like this. Yes, we still have many scattered, but if we apply many times but small load, the flowed material, amount of material increase. And also the negative pressure, the suction have some influence of the damaging process. Yes, and yeah, I have many experimental results, but just skip it. Yes, we also do the shear test and observe the crack surface with and without water. If we apply load, for example, this is the specimen and this is the crack, and we apply shear load, shear force many times. So you can see this is just before loading, just after cracking. And after cracking with water, many, like the cement matrix flow out. Then you can see the aggregate clearly, and some aggregate, also aggregate itself flow out. just small amount of water and just small force, but the repetition may affect the damage state. Yeah. Okay, many results, but just skip it. So now you understand what is the fatigue of concrete, and especially for the bridge slab situation. And I would like to show another example. This is the anchorage of onshore wind turbine foundation like this one. Yes, the last year, of course this year we had very big typhoon, but also the last year we had very big typhoon. And after the typhoon, people found, oh, wind turbine fall down. What happened? Yeah, I went there and checked the failure structure. Sorry, this is Japanese, but not so important. I just explain. So you can see, this is the drawings. The steel tower is connected by the anchor board inside the concrete. But in this case, not anchor board doesn't have any damage, but the joint part of footing and this pedestal part is just divided by some external force. Generally speaking, we have this kind of structure, anchor board or anchoring. Then both can collapse due to the failure of connection part inside the concrete. Then actually Japanese government, not government, the Ministry of Economic something made the investigation team, and the result of the investigation team is why this failure occur, because they said the typhoon wind was more than our expectation, or something wrong operation, mistakes of operation, because the wind turbine has some function to release the additional wind power, but the engineer didn't do that, something like that. But I don't agree. I have doubt. There must be some fatigue problems in here. Then we did many the investigation on site. For example, here is Hokkaido, but Hokkaido is too cold to investigate. Then I just do it the Kyushu area and the near the Yokohama and blah blah blah. Like this one. Because the Japanese government encouraged the local government to make wind turbine in small city. So because the government pretend to consider the environmental problem, so wind energy should be very clean. Then many local government made this kind of wind turbine, but at this moment, there is no specification made by civil engineers. Yes, just simple specification guideline exist, but it was not written by civil engineer. Then I have doubt. Maybe some fatigue of concrete problem should be, exist. Okay. So I show one of the moving. Yeah, you don't need to understand about this one. Okay, let's see. Please see it carefully. This is a concrete foundation. This is the soil. This is my finger. So you can see the moving, vibration. The foundation size is 7 meter width, and the thickness is like 1.8 meter, something like that. Big structure, but it was moving just under the normal wind. Yeah. Because nobody care about the foundation of wind turbine. Then anyway, I choose one of the wind turbine and obtain the drawings. Then measure the real the vibration with the sensor. Just skip the more things. And there are some patterns. Very weak wind and the cut-in speed. Cut-in speed is no operation, power generation. And very good wind speed, moderate speed with the power generation. And if the wind speed is too high, the power generation stop or something like that. And we luckily got some seismic, the earthquake wave motion. Yeah, this is the example. Yes, this W3 is good wind, not so strong, not so weak. So you can see big vibration because the condition is very good. But if the wind speed is too high, it stops to generate wind power. Then we obtain this kind of the wave motion and check the primary mode of the frequency vibration. And yes, you can see this vibration is caused by the normal wind. And this one is the earthquake. Very big impact, and after that dumping. This is the same. And anyway, let's keep. And we made the model by FE analysis, already introduced by Professor Maekawa. And just skip it. Then, okay, we made the model, the real scale model, and I asked, we discussed with my colleague, Dr. Koda in Nihon University. Okay, I want to confirm the accuracy of my model. I want to obtain the real vibration primary mode. But how can we make vibration to the real structure? Then he said, okay, just rely on me. I can do it. Then he took very strong student, one of the team member of judo, and another one is the boxing exercise, muscle training student. Then they pull it. So we obtain this kind of very stable vibration with damping. And the experiment and the analysis match very, very well. Anyway, with this model, we input the vibration obtained from the real structure, then see what happened inside the foundation because we cannot see inside the foundation directly. Then the result is like this one. First, inside the concrete, you can see this horizontal crack around the end of anchor bolt. Then it develops, then finally penetrate the joint part. This is one of the results. But fortunately, this wind turbine is very safe. Please see, this line is the moment of design earthquake, and this another line is operation mode or something like that. But the capacity is much higher than the design. So this case, we don't have any problems. But we did the analysis with different conditions, then can find this kind of development of the horizontal cracks. Then this is the result. Yeah, as Professor Maika explained, this particle means the amplitude stress level, and this horizontal is the number of cycles. Okay. According to our analysis, this case, this wind turbine doesn't have any problem. The stress level is tolerant capacity is much higher than the real stress level. Okay. So this is the conclusion. So now I can say the fatigue of concrete can be a critical issue, but not all structure, but some particular structures with particular conditions. And you can see that in the cyclic water pressure gives some influence. It accelerates the damage of concrete. And finally, this one, steel structure embedded in concrete. This means the steel tower anchored by the anchor bolt in the concrete. This kind of structure needs to assess the possibility of collapse due to the fatigue problem. This is my conclusion. Then, yes, terima kasih. Thank you for your attention.